Hello everyone. No water. Hello everyone. Welcome to the Tech Talks Thursday number 23. We have 3 talks today. First one is from Silvan mühlemann. He will talk about AI agents from prompt to production. I'm very excited because he promised that he's gonna deploy something on Deployo without touching Deployo, so we'll be excited.
Without knowing Deployo?
Oh. And then we have a talk about SCION from Sam, networking stuff, I guess. Yes. And then at the end we have Cyrill talking about live migrations. I hope he can stand.
Yeah, I can.
Because he made an accident last Friday. Perfect, so good. This session is live streamed, so in case you want to watch it or watch future talks, follow us. This is the QR code for our LinkedIn channel. And our next event is already scheduled, I guess the 5th of June. So just join the meetup group on the Tech Talk Thursday group, and then you get notified about new events. So that was it from my side. Handing over to Silvan.
All right. Well, thanks for having me. It's great to be here. It's the first time as a speaker here. I was before as a guest. I think it was 2 years ago, and now Tom convinced me to hold a presentation. I will talk with you about, share with you my experience with autonomous coding agents. Let's start with this picture here. What am I doing here? This is probably the first questions that you are asking yourself, and what I'm here on the bike. I'm doing my weekly workout. I have on the left, you see Swift, the tool that I use for my training, and in the front here you see VS Code. And what I'm doing here is I'm generating code, I'm programming using my voice. And 2 questions that you are asking yourself: why am I doing that, and how am I doing that? The why is, it was just, I think working out on the bike is a bit boring activity, and I wanted my time to pass faster. And what's more interesting and what makes time go fast for me, it's doing a challenging task while coding, producing some code. And the second question, how am I doing that? It is with autonomous coding agents. In that case, it is with Klein and using Mac Whisper to dictate what the agent should develop for me. Now, a question to the audience: who has used Copilot before? All right, almost the majority. Who has used autonomous coding tools like Klein, Windsurf, Cursor, or Eddy? Okay, so the minority. So for you, probably there's not so much new thing. Not so much new information this talk. Maybe I will share some experience about that. And for the others, I will show you how this works and what are my best, what is the best way to make sure that these agents develop the right code for you, that they don't make mistakes. Good. First, who am I? I'm Silvan. I'm CTO of a software development company in Switzerland, in Zurich here. We have 40 developers. And what you see here is not my business, but is what I'm doing on the weekend. So I'm doing a lot of different, developing small little applications. And many of these applications, I would say, I spent weeks to develop them, but nowadays with tools like Klein or RuCode or so, I would have reduced this effort into maybe half an hour. So it dramatically, using such tools dramatically improved my productivity when developing new applications. Now, how does that work? I will make a demo here, and I hope the tools are in a good mood today so that they deliver a nice piece of code here. So I will use my voice here. So I'm at the Tech Talk here, and I would like to make a demonstration of a coding agent. And what I want you to do is to create the reservation tool for this Tech Talk. This means people should be able to see a seat layout. I would say we have 3 rows and 15 seats each. And the user should be able to select the seats and then reserve those seats. And these seats should be then marked in the tool. Do it just in the front end, just for demo purposes, and make sure it's not more than 900 pixels wide. So what you see here on the left side is Klein. That's my favorite extension for generating code. And I will start that now. And now the agent is starting to develop that code. It decides to use an HTML file, CSS file, and JavaScript file. Totally reasonable for such a small application. What you also see in this tool, is the cost that this generates, because the tool that I'm using here is, I don't know if it's visible from the back. Maybe I need to change that. I think I can't do that here. So up to now we have spent 15 cents for that. And what you see here is the agentic workflow. And now this is something interesting that I haven't seen in these other agentic coding tools. What it tries to do is it uses Claude's computer use feature and tries to test the application itself by controlling a browser. And you see it has quite a bit of a weird way to select seats. I didn't give, but it's the first time I see that. You know, I've tried that numerous times, and every time it was a bit different. So it's always a bit of a surprise. So does that work? Still doing something here. Honestly, I find that a bit of a gimmick, because you're much faster if you just open it in the browser and you try it yourself. So yeah, Okay, I see this variant isn't as, doesn't list the seats that have been selected like the other variants. That's interesting. Every time it's a bit different. You can see this is a different one. It looks like this here. So it always depends a bit on the daily mood of the tool. Now, of course, you can guide it more closely than how I did it right now. So here it seems that it's stuck at that point. It doesn't do anything anymore, or it's, let's see if I can resume that. Well, I will skip to the next step, the step that Tom is interested in, how to deploy that. And we're going to use Nine's infrastructure deployo for this. And to do that, I will start here a new task and give the instructions. So I would like you to deploy that application to deployo, and I will provide you the URL to the website where there are instructions how to deploy. So also be aware you have a GitHub MCP server, so you can create a new repository. And I cannot already tell you, create the repository, push the code there, and then deploy it from there via the nctl script. So I know a bit about deployo and the tools from Nine. All right, so I need to provide the website where there is information about deployo. And now what it should do, it should go to the website, fetch the documentation, and then use that to figure out what command line to execute. So what you see here is it's using Firecrawl. That's the tool I'm using to fetch the data from websites. Did it find the information? Okay. Now I have a better understanding of how to deploy static sites to deployo. So it understood what to do. Now it needs to create the GitHub repository. Here I have integrated the GitHub MCP servers, so that extension which allows the agent to talk to GitHub. I will approve that here. So it created the repository. Now it's always doing the same mistake. It's trying to upload the files via an API call. That's not efficient. So I interrupted it. So don't upload the files via API call. That's inefficient. Use the terminal for that. It doesn't probably see my hand movements here, my gestures, and neither my tone. So let's see if it understands what to do. All right, it can now control the terminal here. It commits.
What possibly go wrong? I'm so scared.
All right. Now we have the demo effect. It has some troubles here. 9 control is already installed, huh? 9 NCTL is already installed. You just need to use it. Yeah, I think that looks better. Yeah. Yeah, now it goes. Yeah, sometimes it needs some guidance. It's interesting. I've tried it 4 times. It's the first time I have this behavior. But it knows probably that it's a live demo in front of an audience. So, yeah, you see, it deploys the application, and in a couple of minutes, you will see that it's reachable. Maybe in the meantime, I can say a few things about Klein, my preferred tool here. What I it worked now, huh? Where's the URL? It's here. Okay, the certificate is probably not yet deployed. Let's give it some time here. Yeah, what I can tell you here, what's interesting with this tool, in contrast to Windsurf or Cursor, is that you can freely choose from tons of different models. You can. A second thing I like is that that big choice of MCP server, where you can integrate, let the agent contact Spotify and use that. I don't have a use case at the moment, so that this is very useful in Klein. Let's see if in the meantime, yeah, now we have it. It's deployed, yeah, and it works. We see deployment with deployer is a matter of seconds, yeah. I also used it to deploy an application to Kubernetes, and here's another an example of an application I also built fully with Klein. It's a tool to prepare myself for a meeting. It was a meeting about data security, and I really had a hard time memorizing all these regulations, so I built this tool. It allows to manage questions here. You get statistics. This has been fully done without any line of coding that I did, including the deployment. An open source tool another example is an open source tool to add subtitles to videos using Whisper and FFmpeg. I wanted to show another example where I wanted to show a customer about the difference of performance on an LLM between 1 user and 10 users. And I created this tool 10 minutes after I hanged up the call with this customer. He was impressed that I immediately was able to demonstrate something such a short time after I spoke with him about the topic of LLM performance. So I found many applications in my domain as a CTO for these agentic coding assistants. Yeah, so But of course, I believe you can't use it for everything. And you have to follow certain rules when you use them. Otherwise, you will be frustrated. Yeah. So to wrap up what my setup was here in that example, I use Mac Whisper to dictate. I had Klein in VS Code as an open source free extension to provide these agentic capabilities. Klein is connected to Sonnet 3.7. That's just my favorite one. I've tried many of these of the models and services. I'm using Firecrawl to get information from websites, Postgres, and GitHub. And these are all connected via this MCP protocol, so it's highly extensible. And Klein is using files and terminal and the browser, like I demonstrated that before. I said that some experience that I made about when to use it and when not to use it. At the moment, in 1 year, it might be different. For me, it works best for small code bases. I haven't used it for really our production large code bases that we develop at the office. If you use it for Python, TypeScript, Tailwind, these kind of things, it works very well because it has that knowledge baked in. Don't try to use it for languages like brainfuck. Anyone knows that language? Okay. Well, I haven't tried it. Maybe it works. It works nicely for backend heavy tasks. It cannot really see yet. It doesn't have a sense of aesthetic. It's my experience. That's why for front-end heavy tasks, I don't use it that much, unless I don't care about the design. However, I read today about V0dev. V0dev, I think it's... Does anyone know V0dev? Okay. Is it good, the quality of the design that it produces?
I mean, it's okay, but I haven't used it. There's just no idea.
Ah, okay. Okay, so yeah. Apparently, it's good. And then I recommend to use for technologies that you understand, because it does make mistake, and eventually it gets stuck in loops, and you need to fix those loops. You need to help it sometimes. So although I've heard of people who claim to have built a whole application without the computer science degree, without knowing how to code, but I'm not sure if the code quality is really, if it's really that maintainable, what you get. No. Yeah, then 4 things that that helped me get most of the productivity, most of the best quality out of these tools is there's this thing called memory bank. It's like an extension or a custom instruction for Klein, where you tell the agent to write down every thought, the application structure and the project structure into files. And so after every task, it should write the information into files. And then when a new session is started, it should first read what is in those files to understand the general project structure. And this I made the same experience like this user here. Once you add memory bank and populate it, it works like magic. And that's also my experience. And of course, keeping the file under 250 lines of code, you should anyhow do that, even if you do manual development. So the same rules apply to agentic coding and manual coding. Then verify the produced code carefully. So this developer here, it's too small for you to read, said, I tried the AI approach here again. It provided me a script, but it didn't work. And that's funnily, after some time, he said, I tried to debug. I asked, what model did you use? And then suddenly he said, oh, you know, I'm wrong here. Sorry, the code is working. So what's interesting here is actually that he was a bit biased and he expected errors here. And although in that case, he didn't really verify the code very carefully. Then I like generating unit tests to the code, or have the agent generate unit tests. And the most important thing is that you get familiar with those tools, get a feeling, what can it do, where are the limitations, and then you can become friends with those agents and also use it, I don't know, on your, to write application on your stationary bike, on the treadmill, or even while doing the dishes, you can create an application. Yeah, so this wraps it up. Are there any questions or comments? I know some people are experienced with, you nodded often, you have some experience with that kind of agentic tools.
I'm just wondering for how long you use those agentic tools and how you feel like it developed over time in terms of the more complex code base, which you already discussed you should not use yet. Do you feel like we're getting there at some point, or?
Oh, I definitely, so I'm using them for, I think my first contact point was with windsurf. It was in November. And there has been some development since then, but windsurf was a big step forward. I wasn't really happy with Cursor, and I'm sure that we will get there where the agents have a better understanding about the whole code base, or these tools, they include some means to help the agents to get the context already built in the tool. So I believe that engineers, for the simple task, will always use those tools eventually. Yeah. No more boring tasks anymore for us.
Yeah, I agree.
Yeah.
I just think one remark, what would be great is if they would be capable to say, I'm not capable in doing that. This is the one thing I'm missing when working with those things. It's like always there to please and never able to say, I think you should validate what I did.
Yeah, that's true. That's a really good point. Yeah. Yeah.
I find it funny because you always kind of ask it, make it better, and it sometimes finds like its own security bugs, for example.
Uh-huh.
Are you sure it's secure? Oh, no, it's not.
Yeah, that's true. Yeah.
I have one question. So how often you still drop into editing by hand? You know, you do everything by voice, but how often you...
Yeah, honestly, that editing by voice was a bit of a show here. Although the one with on the bike was for real. That was really not set up. I think when I'm at home, I do it by voice, and I think 75% of the cases, and at the office, I don't want to disturb everyone, so I type.
No. One more question. So how much does your weekend projects cost you? Because this one was more like 50 cents.
Yeah, the older one, the cost went probably from, you mean, token-wise, the quiz generator was $10, the one, yeah.
You should try multiple things like cursor, windsor, like for some more complex. What do you prefer, or what do you notice in GitHub? I try Copilot.
Yeah.
Cursor is okay.
Yeah.
I'm using it a lot, but the other
I moved. Yeah. So I started to work seriously with windsurf, and then eventually I just felt it didn't work that nicely anymore. I switched to Roo code, and now I'm using Klein, but it's also always like a gut feeling. I can't tell you exactly why I did those moves. Maybe it is the, I know for Klein, for example, I like that bar that you can see how much of the context is being used and to see the cost. So yeah, I don't have solid reasoning why I'm using Klein. What I like about Klein is that it's VS Code, it's open source, and you don't have to pay a monthly fee. Yeah. Yeah. What? Yeah.
But I don't know how does it work. You have to have subscriptions to the other.
Yes. Cursor and Windsurf, they have subscriptions. Yeah. And Klein and Roo code, or you just provide your API key.
You have to have an account with
Yeah.
the other providers and so on.
Exactly. There I'm paying Anthropic or.
So
Yeah.
have you tried it with local LLM models?
Yeah, I tried it, but it didn't work.
Make
Nice.
mini cluster.
Excuse me?
So make mini clusters required. So you need like a terabyte of memory and something like that.
Yeah, I heard about that. Yeah, maybe that's a different thing. It works. Yeah. Mm. Yeah.
But it's really so the CloudSonnet 3.7. That's a huge step forward.
Mm-hmm.
So it's all the earlier stuff is not that good.
Yeah, I think so too. Yeah. Yeah. What tool are you using?
I worked with Klein as well. I tried Cursor, but I didn't like the monthly payments.
Yeah.
So, and then I also get a step back because I felt like and at some point they're going to offer me to hire their engineers, which are models as well and agents. So,
Yeah. Mm-hmm.
So yeah, let's be careful about that.
Yeah. Yeah. So you also like the control over models, the transparency that Klein or Roo code is providing. Yeah. Okay.
I have one more question. So you say you like to generate your unit tests or tests
Mm-hmm.
with the AI, but shouldn't you be in control? Like you provide the test. If you already have the AI generating the code, and then the AI generates also the test.
Yeah, but
there's the human in the loop. Like, wouldn't you use that as a verification?
it has two reasons. One is unit tests are often for me easier to read than the actual code. Do I have the example here? And the second thing is, with the unit test, I can let the AI test its code by itself. It's kind of a self-test, and it showed to me that it can help. It increases the bug detection rate if you have unit tests.
Interesting.
Yeah.
But it could also just generate a test that totally kind of missed the bug that it introduced itself, right? Because it looks at the code, it's like,
Yeah.
okay, yeah, I need to
Yeah,
test it.
absolutely. You have to review at least the unit test. That's
No, absolutely.
Yeah.
But my experience with unit tests is essentially because there's way much more unit tests in a wall than the actual code. So
Mhm.
it seems to have way much more training data for that. At least that's my experience with front-end code.
Mhm.
I would assume.
Yeah, cool. Looking at the time, huh? So,
Yeah? Right, I'm good. Yeah. All right. Hello, everyone. My name is Sam. I'm the CTO of Anapaya. Very happy to be here. Tim invited me. I'm probably a bit far away from what you guys do. We're creating a new internet. That sounds bold, but let me today give you a little bit of insight into what we're doing, what this SCION thing is, how we use it, how it can be used, what kind of use case it has. But let me first ask you, who here, with a show of hand, has heard about SCION? Well, 4. I've expected less, so it's not too bad. Well, actually, Tim, yes. All right. Let me first maybe frame the problem a little bit, or motivate why would we do something like creating a new internet, right? What's happening today is that the internet is becoming the backbone for critical infrastructure. I mean, it has to be the backbone for, video streaming, social media, all of that jazz for a long time. But also critical infrastructure more and more needs to adopt the internet. Things like, healthcare, electronic patient dossiers, or how doctors and hospitals exchange data or analyze cancer through cancer boards. The whole financial system, especially also with new fintech, open banking APIs, etc. This all moves to the internet. Today we have control of this distributed energy grid. A lot of IoT things, all being dependent on the internet. And some of these things you really don't want to be on the internet, right? The ones of you that work with networks, work with the internet, there's kind of a big risk out there, right? And this is just a claim that I make here. The internet is actually very outdated. Of course, it has been a big success story based on a pretty old protocol that no one ever believed will scale to the size it does today. So what are the problems, right? It's the internet itself that's maybe due to its own success is inherently very risky, right? Today, if you put something on the internet, it promises it connects everything with anyone, right? That's the promise of the internet. And that's fine for Google search, and that's fine for Instagram and all these big services. Now, do you want your electronic patient record being out there, exposed to potentially 18 billion devices, right? Of course, we build stuff, like we build firewalls, we build intrusion detection, we build all of these things, but fundamentally, if I put something on the internet, it's out there, right? It's on by default, and then we try to do blacklisting, which I believe, like this attack surface, is a big risk. Another thing with the internet is that you cannot control how your data travels through the network, right? And that might not matter for you if you browse Instagram, of course not. But it can matter a lot if you think about e-voting applications, or if you think about financial information that is quite often regulated, right? That needs to stay within a certain jurisdiction. We have a lot of laws that say, well, data at rest needs to stay within Switzerland, for example. And we have similar regulations that say, well, for these kind of applications, data can never leave Switzerland or the Swiss jurisdiction, right? That precludes basically the internet. On the internet, you choose your service provider, or maybe your 2 upstreams if you're your own VGPAS, and then you send off your traffic, and there it goes. You have absolutely no control, no guarantees. For one, nor do you have any insight, right? If something goes wrong, you don't know where things go wrong, because you don't know how the network looks like. Of course, you can use things like trace route and pings and whatnot to try and figure out what network path is being used. But it's all more a black magic, a voodoo, a black art than actual science. And because you're at the leisure of kind of the internet, and the internet is driven by economics incentives, your data quite often is actually also not sent over the best performing path, right? It's more like the cheapest path. Everybody is like handing off the traffic as quickly as possible because it's off your network, it doesn't cost me. So that quite often leads to very suboptimal routes. And none of this you can influence. And this is where we come in with SCION. So SCION itself is a new internet architecture. Technically, or you can think about it as a layer 3 protocol. It has a control plane, and I will talk about this, and it has a data plane. The control plane is roughly a replacement for BGP, or an alternative for BGP. And the data plane is basically how then packets get forwarded, so on the IP. So the SCION data plane is IP, the SCION control plane is BGP, like equivalence, right? Now, SCION has usually 3 pillars. That's what I usually how I introduce it. The most important of which is this notion of path control, right? What does that mean? That means I, as a sender of data, I get a selection of paths from the network, and I can make a choice. Which one do I want to use to send my data through the network, right? And that immediately opens up, of course, this use case of geo-fencing, right? I need to ensure that certain data never leaves a certain jurisdiction. So I will only choose paths that go through, let's say, Swiss networks, European networks, never cross Chinese networks, whatever it is, right? But it also lets me do other things, right? I have applications, if I do video conferencing, or gaming, or any kind of real-time application, I'm very interested in having a low latency and a very predictable jitter, right? If I do a large file transfer, or if I mirror my database to a backup site, I don't care about latency at all. All I want is throughput, right? And actually, the path that gives you the best throughput or the best bandwidth is often not the path that gives you the lowest latency. Now, if you have control over that, you can use the network in a much more optimal way, right? You can choose the low latency path for your video streaming video conferencing, and the high throughput path, or even multiple high throughput paths together to increase bandwidth, right? So that's the path control from the perspective of a sender. Now, it always, to some of you that might be familiar with networking technologies, this sounds a bit like source routing, and we had that in the past, and it didn't scale, and why are you trying to do this? Because it's not fully source routing in the sense that the source I see the network, and I can choose any possible path, right? It's different in a way that the network offers me a set of possible paths, and amongst them I can select one. But that also means, and that's the crucial bit, that me as, for example, a provider of a service, right? I'm usually the receiver. I can now control whom I make this service available on the network level, like who can see my service. If I want Tim to connect to my service, I give him path information. I make sure that the path information is available to Tim to reach me. If I want to keep out Silvan, sorry, I just use you because I know your name now. I will simply not tell Silvan about any path information that leads to me, and that's in my control because I'm the receiver, right? I can control who gets my path information, and then for Silvan, my service doesn't even exist, right? I don't need to put up then a firewall because all of you can access it and keep you out and try to identify Tim and let him through and identify and kind of keep everybody else out, and then you have source IP spoofing, all kind of things. It's just a much cleaner way of expressing who can access my service or who can see my service on the network level. Of course, that's also great for availability because denial of service is a thing. Then there are 2 more aspects. The isolation domain, that's kind of a new aspect that groups together networks or autonomous system in kind of a common trust anchor or a common governance framework. So think of isolation domains as kind of like top-level domains, right? Every country would have roughly an isolation domain. That's how we envision it. And then you have purpose-built isolation domains, such as a banking isolation domain, maybe a defense or a Swiss defense isolation domain, and so on. And the nice thing about isolation domains is they provide network sovereignty. So to make all of this secure, there's of course there are certificates involved on the control plane. These are always rooted in some trust anchor, and that trust anchor is defined by the isolation domain. So I can say, good, Switzerland defines kind of a governance framework. I can be part of the Swiss isolation domain if I get the certificate, and the Swiss isolation domain can set up a governance. Okay, you need to be a Swiss business, for example, to be in there, or a Swiss resident to get something like this. In the banking world, you could say, well, you need a banking license, and you can build these kind of trusted isolation domains that are independent of others, and where also from the outside, nobody can revoke a certain key and then you're offline, which could totally happen, for example, today with RPKI or DNSSEC. Basically, the keys are controlled by organizations that are very close to the US, and they can totally disconnect entire parts of the internet. So that was very theoretical. Still going to be a bit more theoretical, but on a high level, how this works. So what you see here are these 3 isolation domains, right? And in these isolation domains, you have SCION networks. We call them also autonomous systems, similar to how the internet is made up of autonomous systems. And then you have kind of each isolation domain has a core. These are usually the tier 1, tier 2 providers of a certain region, for example. And they are essentially here to provide connectivity, of course, within the isolation domain, but then also across these, right? And then you have on the control plane a pathfinding algorithm, or the control plane is there to define path segments or find path segments. There are 2 layers to this. One is intra-isolation domain, so path construction beacons, they flow from the core of the networks towards the edge, right, from L to O to S, and would collect path information. That's then a path segment that goes from L over O to S, or vice versa, right? This happens also in this isolation domain, and then you have the same happening between these isolation domains. So a SCION path then becomes a combination of 1, 2, or 3 path segments, right? In 3 path segments, you can reach any other connected place if that path is available to you, right? If this is, again, my example, I'm here, I can totally make these paths that lead to me not available to everybody, right? And then I'm also not visible to everybody. Nevertheless, then on the data plane, what you do is basically, if you're in F, you ask the network, hey, give me path segments that lead to S. And in F, of course, F doesn't know anything yet. It knows from this beaconing process that how it reaches A and B, right? So it asks A and B. A and B, they don't know about S, but they know that S is in this orange isolation domain, and they know from this part here how to get to this orange isolation domain. So they will ask K and L and M, and they know because S probably registers their path in the path registries here, right? And then, of course, you can cache this information. You don't need to do this on every packet or on every time you want to establish a connection. But you really put a form of these paths into the packet then, a reduced form. That's an overhead. That's what you have to pay for SCION connectivity, right? Each packet has roughly 80 bytes of overhead, depending on how long that path is. On the flip side, the routers that forward these packets, they're really simple. Because IP forwarding is, you look at the destination address, you then do a longest prefix match in a huge routing table, right? In an internet routing table, you have 2 million entries, and you need to do this, like to do this at line rate, you need to have specialized hardware, really expensive one. And here, the routing decision is encoded in the packet. So all a SCION router needs to do is actually look at this packet and then verify that this packet header here is correct. There's some symmetric cryptography involved there. It's basically an AES computation, which is very cheap, but it's the most expensive operation in SCION forwarding. It's very cheap compared to a longest prefix match in a huge routing table. It's independent of the network size, right? This stuff here will always be the same size. It doesn't depend on how many other routes are in there. And C, it's basically hardware accelerated on any commodity platform. So even on commodity server hardware, we can do hundreds of gigabits of forwarding of SCION traffic, right? So we can go quite far until we need to have custom silicon. And then, of course, all of this on the data plane, but also these path segments on the control plane, these are cryptographically secured. They give you the guarantee that once they have been created, they cannot be changed anymore. If I claims to be on that path, they're really on that path, right? Of course, that is always relative to some trust anchor. So much like the web PKI. So that has been very abstract. How do you use this today? This is where we come in. We're a spin-off of the ETH, and so far, all of that we have basically developed at ETH, right? And Anapaya was created to build the technology that this can actually be used in the real world, right? And the real world today looks like this. You have a backbone network, ISPs, Swisscom, Sunrise, British Telecom, Colt. They need to deploy SCION routers. Our product is called Core because it's at the core of the network, right? And think of these SCION routers, they're waypoints on a SCION path, right? A SCION path is a series of interfaces of this on these SCION routers. The more SCION routers you have in the network, the more diverse your network, the more operators you have, the more diverse your network, the more differentiated paths you have. But that's the cost. You need to have this backbone network that also creates and finds these paths, etc. Right? And then you have kind of the user side. The user can be individual users, but they can also be, kind of headquarters, virtual cloud deployments, branch offices, you name it. Now, none of these networks there at the edge or applications that run in here, they know anything about SCION, of course not. And requiring that we would upgrade applications or build SCION support into Linux or Mac or Windows would be, I mean, the proposition to attack the foundation of the internet is crazy enough, but if you would need to upgrade applications, you have lost from day one. So this is where the IP in SCION tunneling gateway comes in. We call this an edge. That's just our product name. Its main purpose is to take IP traffic, encapsulate it in SCION traffic, and based on the destination, then make a path decision to the other side where it gets decapsulated, right? So IP is tunneled within SCION, so to the applications and the users of this network, this is completely transparent. Of course, that's the primary purpose. The secondary purpose is now also, this is the thing that makes the decisions of which path is the most optimal one, or that you configure with your security policies or whatnot, right? They come in different flavors. In the cloud, you can spin up a virtual machine and run this as a virtual router. Maybe in your headquarter DC, you have this as a physical appliance. Or then they also come as kind of carrier-grade version of this, right? Where Swisscom, for example, operates a bunch of these, such that these end users here, or these little IoT devices here, they don't need to run an entire IP and SCION tunneling gateway themselves, but they basically use the ones provided by the ISP, giving access to the SCION internet to all of these entities. And just to illustrate how this works, right, the IP and SCION tunneling, you have the sender there. It sends, in this case, a TCP IP stream. It could be an IPsec stream. It could be a UDP IP, QUIC, whatever. Just needs to be IPv4 or IPv6. It goes into that edge gateway here, right? The edge gateway looks at the destination address, and it, of course, it needs to have a routing table because essentially it's still dealing with IP traffic. It learns from other such edge gateways through a dynamic routing protocol what kind of prefixes they announce, right? So it figures out how the destination is now in this SCION network here, and at that point it knows where, on the SCION level, where it needs to go, right? And then it can make a path decision. And the path decision is always a combination of what path are even available to me. The paths that are available to me is dependent on the destination, but also on the core network in between, right? They all have a say in what paths are available. And then it makes a decision based on, okay, what kind of security policies I have configured and what kind of performance I know these paths have. And to give you a little bit more of an idea of how this can look like, we have a tool, a cloud orchestrator. It's called the console. And we have a demo version of it. This is the demo version, but the live version looks exactly the same. That's another powerful thing about SCION, right? You know all these paths, and based on these paths, you can actually graph the network, and you know which paths are being used to communicate to the other side. So you can visualize all of this. And now I didn't manage to mirror my screen, so bear with me as I find my cursor somewhere. Yay. Right, if I'm, for example, interested in my corp network, which is headquarters, Paris office, Ashburn office, I can look at this and see, okay, these are the different streams I have, some voice over IP traffic, some TCP traffic, right? If I click on any of these paths, I get insight, okay, these go from, from the HQ to Cyberlink, and VTX and Swisscom, Switzerland to Swisscom, the US AS, and then to the Ashburn office, right? It's even payload is encrypted. We have this latency, throughput, etc. Right? We get this. Imagine getting this on the internet level, right? This is not a private network that we own, right? This is an internet, well, a SCION internet, and we can get this level of insight, right? So that's one thing. The other thing then is also how powerful it is to have to do traffic engineering. So if I, for this, I use now another domain. So here, for example, I have two kinds of traffic. Sensitive, and we just label them sensitive and non-sensitive, right? And you can look at the sensitive traffic, and it has some path policy, and we can look at what the path policy is or how it's defined, but it like the name should suggest what the path policy express, right? It's Switzerland, and it should prefer the sunrise axis. And then the failover is just Swiss paths only. And the Swiss networks here are encoded in this light blue, right? You can see here, this is the Switzerland isolation domain. The European is the dark blue, and then the North American is the green one, right? And we have the non-sensitive, and here we send this over, the Cyberlink axis here. So you see, we prefer this one. If that is not available, we fall back to the Switzerland only. But if that's not available, we're still okay with going through Europe, right? Whereas for the sensitive one, we said only Switzerland. If no Swiss path is available, well, then we don't send the traffic. Now, because this is a demo, we can, or a demo environment, by the way, you can play with this yourself. Just go to console-demo.anapaya.net. We can bring down links or ISPs. So for example, if I bring down this link here, then you see it failed over to this alternative path here, right? You can also bring down another one here, and it fails over to this one. It's, of course, you don't have to, now you think, yeah, this is a demo, that's how fast it goes. In reality, it also goes pretty much this fast, because you get immediate feedback when a link is down, and basically within one round trip time, you can fail over to another one. So it's not so far from the truth, this failover behavior.
Can I ask a question?
Sure.
Let's say those routes are down and you only have the sensitive traffic you want to route. Do you have to manually confirm an alternative route, or will it just say we're going to stop the traffic here?
Well, right now it would say we're going to stop the traffic, right? If now I have to be careful. If I bring down, I still have a path then. Let's say bring down. Now I don't have any paths anymore. How can I force that there is here, right? Okay, so now the only path, it's a bit unfortunate that the color scheme changes because it uses determinism, like just the first one is blue and so on. You see, the only active one is still non-sensitive. It's the only, right now there is only a path that goes via Europe, right? And if I actually also kill the path via Europe and force it to go via the US, oh, I see. I played around with it, and there was already a US path filter in the demo. Never mind. I should have reloaded. Anyway, it would have stopped working. And what I wanted to show is actually if I change the path filter for Switzerland and in Europe, actually this is also pretty cool, right? You can define these path filters, and you can get a preview of the impact it has, right? So here, this is the path filter Switzerland and Europe between headquarters and in your destination here, and it shows you all the possible paths that, or possible links that you might take, and you see the US one is grayed out, or yeah, redded out. So you basically get the preview of your path policy before you actually deploy it, and all of that, yeah, it's just based on having this path information available, right? If you have the Switzerland only, then you see the preview here. Well, it does not allow any of these European or US networks. But anyway, you can then configure and apply a new path filter, and it would actually, you know, pick that up and route accordingly. And yeah. Oh no, it doesn't have a path. Okay, maybe the demo is broken. I just need to reload it, and then it flows again. This is front end only, so you cannot really break anything, right? Yeah, but it's also not very believable now that I had to reload. Anyway, you get the point. It's actually in production you wouldn't play around like this because you cannot kill stuff, but it's roughly how it looks, right? And just to give you an idea, what is possible with this technology on an internet level. Yeah, let me go back. So you might wonder what kind of use cases today are kind of addressed today. This was our first and still most prominent use case, kind of a multi-provider MPLS-like federated network, right? This is the Swiss Finance Network, Secure Swiss Finance Network. It connects today over 100 banks, nationally and internationally. It's called Secure Swiss Finance Network, but it has a lot of international players as well, together, and they do all kinds of interbanking data exchange, the most prominent of which would be the Swiss interbank clearing. That clears up to 400 billion Swiss francs every day. If this one is down, you actually read it in the news. And this is, since last summer, everything has migrated to a SCION-based network, right? And the reason for this was, or the use case was, before that it was kind of 6 at the center, and everybody had to have kind of a dark fiber or least line to 6 to have the star topology. But they could only use it to communicate with 6, right? They could not use it to communicate, like there are a lot of banks that are service providers for other banks, or now fintechs are in there, right? They do a lot of interaction with other banks. So this is why also the internet gets adopted more and more, right? Because in this private network, this any kind of communication is not possible. So they wanted something that allowed this any-to-any communication. They wanted something where they could control who is part of this network, right? And SCION and their isolation domains, they give you the key for that, right? So the Swiss National Bank and SIX as kind of the governance of this framework, of this isolation domain, sorry, they can control that only eligible entities enter this network by handing out certificates. You can only be part of an isolation domain if you have a certificate for that isolation domain. So if you control the CA, you control by extension who is part of it. Like even if Swisscom would try to connect a rogue bank from somewhere, if they don't have a certificate from SIX, they wouldn't be part of this network. And they wanted this to be multi-provider, so no single provider lock-in, etc. So this is a primary use case, is multi-provider networks, kind of site-to-site connectivity. And we have a couple of others like this, but this is the biggest one, right? And it's very resilient and blah, blah, blah. Second use case, and this might be more interesting also for 9 or for hosters in general. It's basically providing a service and controlling where that service is exposed, right? And this is the gate infrastructure that we have built. So basically what you have here is you have your different sites. That could be your data center, right? And you have users, a set of users that need to connect to this. Today, this set of users could be, users in Switzerland, right? Because in Switzerland, we have 100% coverage through these IP in SCION gateways run by the providers here. And basically, if you have a service that should only be or primarily be accessed from users in Switzerland, you can make it available in the SCION internet and only hand out your paths to these gate providers, right? And it will be totally inaccessible from the internet. Basically reducing your attack surface from 18 billion devices down to 8 million people, let's say. We have done that a couple of times now. These are the numbers for medium-sized Swiss bank that moved their remote access to this SCION internet, right? They said, okay, our employees work from Switzerland, so we need to guarantee the uptime for Switzerland. They had an internet-connected VPN access point and a SCION one, and they just compared, what do we get? You get a lot of scans. Nobody cares about those very much. But you also get almost 90,000 intrusion attempts. And these are, targeted attacks, as in try to use credentials that they phished somehow, try to send an attack payload that exploits some weakness that they have in their VPN solution or a service behind it. All of that basically went down to 0. Now, it doesn't need to be 0, right? The attacker can sit in Switzerland, and then you have maybe 1 or 2, but it's drastically reduced, right? It's not magic or a panacea that solves all your problems. It's just an attack surface reduction. Of course, there's the use case where you still need to be reachable also from the internet everywhere. And so what you do then is you expose yourself to the internet and to the SCION internet. And if you're under pressure, for example, a DDoS attack, you cut the internet leg, right? And if 95% of your customers are within this SCION protected area, then you would lose 5% of your business instead of 100%. So that might be interesting also for something like 9. But I'm not here to sell anything. I'm here to educate, of course. Maybe as a final bit, where we are in Switzerland. So this SCION thing is not just a theoretical idea anymore. I would say in Switzerland it has become a standard for critical infrastructure. We started in finance, right? That's still our biggest network. We have healthcare. This uses a lot this gate infrastructure connecting more than 50,000 doctors to hospitals, to this health infonet, this kind of a healthcare infrastructure provider, centralized. And this is now all taken off the internet, like a national infrastructure taken off the internet into a sovereign Swiss network, but still accessible by all of you, right? We're working with the utilities. We deployed this year, and actually what just went live a couple of weeks ago is also retail payments. So this is now kind of an extension of this for all the merchants and all the payment terminals. We're working now on internationalization. We just landed in Benelux and France and Germany. This is ongoing, and we hope that we can replicate this, of course, also internationally. And yeah, I'm sorry, I'm slightly over time. I hope I could give you a brief overview of what this SCION bit is. Happy to take any questions. I'm also around afterwards. Yeah, thanks a lot. Yes.
So does it mean that ISP has to essentially provide SCION if you want to use it?
So the question was whether your ISP needs to provide SCION to use it. Ish. Let me say it this way. So For example, to cover the entirety of Switzerland, we have the big ones, Sunrise and Swisscom. They together have like 75–80% of the market share, right? They have native sign available. And then there's a huge long tail of small ISPs. And for that, we basically run such gate infrastructure at the Swiss Internet Exchange and do direct peering with them, right? And make sure that basically extend our network to their network through filtering and BGP announcements and whatnot. It's a bit of a, it's not a hack, it's actually very clean, but it allows us to aggregate a lot of these small networks to still give them access to the SCION internet. Now, for you personally, the SCION internet is not yet very interesting because there's not a lot of content on it yet, right? If you have, if you of course have an electronic patient record that you would access via the SIM platform, then you would go through the SCION internet today, even if you don't know it. But generally, you're right. The cost of SCION is that we need the network operators to deploy these SCION routers. And that's also what makes it very challenging and very dragging to expand. Right? This is not an over-the-top internet solution. It's really something at the network level. It doesn't require new physical infrastructure, but it requires new networking, kind of logical networking infrastructure. And there we need the ISPs.
Good. So thank you. If you have more questions, you can ask him afterwards.
Yes.
So, thank you.
Thank you. just quickly check this. No. Maybe I need to restart this. Let's get started. All good? All right. So, thanks for your patience. Welcome to my talk about migrating containers on Kubernetes. I had a snowboard accident last week, so this is a bit rushed. So, quick recap for probably all of you who don't know what ZeroPod is. So, ZeroPod is a new container runtime that I've been developing. It basically uses snapshots, process snapshots to snapshot unused containers to disk, and then restore them on use again. So it can restore containers in sub-second delay once a request comes in, and it's basically just to save on resources for unused infrastructure. So let's say you have 100 pods on a node, maybe 50 pods of 50 pods on this node are rarely used, maybe once a day, maybe 5 times a day, it doesn't really matter. ZeroPod will take care of snapshotting it when it's not in use for a specified amount of time. You can watch my talk I gave at the Kubernetes Community Day last year. This just introduces ZeroPod by itself. But yeah, there was one big issue, or like one topic that came up. I think it was also asked at this presentation. What basically happens if your full node dies that had such ZeroPods on it? Now you have the problem that you're basically over provisioned quite a bit, right? So all these pods need to fail over to new nodes. So now, depending on the environment, your autoscaler might spawn 2 or 3 new nodes just to allocate these pods that have died. And then after some time, they will scale down to 0 again, so it will scale down the nodes again. So you have this sort of, what is it called? The Hamburger effect? I don't know the English word. But yeah, you have this sort of scaling effect that will happen. And yeah, looks kind of like this, where your containers get stuck. So one idea, we could just migrate these containers to other nodes because we already have the snapshots on disk. That's what it does, right? ZeroPod takes a snapshot of the whole process tree. It stores it on the disk, on the local disk. So you would just simply need to transfer these to the new node, and then you could even, the new container would not even need to start. You could just wait there for requests, and all the state would be transferred because the in-memory state was dumped. So that's at least the idea. So yeah, I'll quickly show that. Hopefully it installed. So I had to set up a new cluster just now. Get runtime class, that's always the thing to check. Yes, it's installed.
So I think it should work. So what I have here is just a local kind cluster. For demonstration purposes, this should work on any Kubernetes cluster, depending on some things I will talk about later. But theoretically, you can just install this on any Kubernetes cluster. And as I've said, it's a runtime, so it's exposed as a runtime class. So if you're familiar with Kubernetes in your pod, you can basically say runtime class and then specify a handler for this pod. And this will make sure that your pod is being created or handled by ZeroPod. And I have this demo 1 YAML here. It's just a really simple deployment. It's called Freezer. I'll explain why later. And it has, as I've said, here it has the runtime class ZeroPod. That's the only thing that makes this a special pod, essentially. And some annotations, but yeah. And then I have a service, and it's just a node port, so I can show you this. Yeah, I'm just going to apply this. Demo 1. So it should start up here once it's able to pull the image. And yes. Okay, I'm really glad that works. So here, this is what this pod returns. It's just a little JSON. It has a timestamp with the last request and last freeze duration. Don't pay too much attention yet. And data. So this is just to show that we can retain data. So I can now do a post request, and I'll just post this data to the service. So the process now has stored in data hello TTT. So this is just to show the persistence. And up here, I'll just do this, show labels. So ZeroPod will actually tell you via labels the state of the container. So I now see this is scaled down. And if I make a request, you see it is running, and after 5 seconds, it will scale down again. And this is, you basically don't notice it, right? But it checkpoints it to disk and restores it that quickly. You see the last freeze duration. This is, I think, microseconds, but it's like 150 milliseconds. Oh no, actually it counts how long it was scaled down. So it doesn't really make sense in this scenario. But anyway, what we also have is these migration objects. So we said we want to migrate these scaled down pods somehow, right? So let's assume this node has 100 of these. And I actually need to check on which node this is running. It's running on the TTT worker. And I have 2 workers here. So now I'm going to go ahead and simulate like a drain. So let's say there's maintenance. You want to drain this node completely. And you want all the pods to fail over to another node. So as soon as I issue this statement, you should see a new migration appear down here. And a new pod will be scheduled on the new node. And it should start in scaled down state. Yes, you can see it's pending. It needs to download the container image. That's why it took a bit. And it's a bit hard to see because there's lots of output. But you see here container creating, and it started in scaled down state, essentially. And I can also show you this. So if I go to the second node and just look at my process tree, I just see the ZeroPod shim here. This is the container runtime shim, and there's no process below it. And if I again do a get, my data is still here, and now the process is running. So it stored the data. It stopped again. So it stored the data, it migrated from one node to another node, everything is retained. So that's the offline migration. Here's a little diagram. How does this work? So we have the node A. Here is where we demonstrated the old pod. We deleted that pod by draining. You can also just delete the pod. What will happen then is the shim is actually 0 pod in this case. It will talk to another component of it, the node component that's present on every node. This node component then will notices, okay, you want to evacuate this node. So it will create that migration object that you've seen. And then the fresh pod that spawned on the other node, it will also contact 0 pod node on start and notice, oh, there's a matching migration. So I don't need to start fresh. I can start with the migrated state. And yeah, it claims that migration, so it can only happen once. So you don't run into weird issues. So this is all coordinated by the Kubernetes API. And yeah, make sure that you only one pod can migrate to one pod and not sort of weird scenarios where 3 pods would claim the same migration. And then all it needs to do is pull that image. And so far it's just making an MTLS connection via the pod network, and it pulls that container image. I just put it in a tar. Yeah, that's it. So once I had implemented this, I thought to myself, what about running containers? Can they also be migrated? Why just handle scaled down ones? So as you might know, VM live migration, it's been a thing forever. I think 15 plus years. It basically works in different strategies. Sometimes there's pre-copy or post-copy. It just means that when you make a VM migration, it will copy all the memory of the running VM to a new node. Then it will basically copy just the diff, what has been added to that VM over time. And then there will be a cutoff point where it decides, okay, now I can stop the VM at the old machine, transfer over everything that hasn't been transferred yet. That's the pause time, and then it will continue running. And this sort of pause time, getting that down to basically 0 is the big thing, right? You want to have this migration smoothly that the user basically doesn't even notice it. So I'm using CRIU for the whole checkpointing thing, and CRIU already technically supports pre-copy. They call it iterative migration. I've linked to their docs here, or post-copy, which is lazy migration. The two can even be combined to optimize for performance. So yeah, we'll do it live. That's the second demo. Let me just delete the first demo. Oh, and by the way, now you'll see that pod, it takes a bit longer than usual to terminate. That's because it actually needs to wait. Maybe there would be a pod to migrate to, right? So it created a migration here. Yes, and now it's unclaimed. After 10 seconds, it gave up. There's no new pod coming, so it just gave up. I'll just clean up these migrations. Okay, and yeah, let me clear that. I'll create the demo 2. The demo 2 is basically the same thing, same pod, but I changed the arguments a bit of the pod. Maybe I can show it quickly. So now it allocates 1 gigabyte, I think. Yeah, I think that's megabytes. And I've changed the scale down duration to 10 minutes. So this won't scale down until 10 minutes. So I have enough time to live migrate. And yeah, I just gave it a gigabyte of memory. So you can see that how does this affect the actual time for the migration. Let me get out of here. Actually need to uncordon the other node. Okay. check again where this pod is running. So it's running on the TT worker 2 this time. So I need to drain. No, it's the same again. No, it's the other way around. I need to drain the second one. So it will fail over to the first node. And I'll do the same again. I'll watch the migrations down here. And if I do this, that's it. It's already migrated. Oh, I forgot something. I forgot to put in state. But yeah, let me do it again. So I don't have any data here. That isn't a good demo, right? So let me put in some data live. OK, now I got data. Now I need to uncordon again. OK. Now I'm going to migrate again. All right, completed. I can curl, and you see the data is still there. And in the migration, you see it. There's a duration here. And this is sort of an approximation. Freezer, the tool here, it also internally tries to figure out how long was it paused for. It does that by just writing something in memory every millisecond, and then if a timestamp, and then if the timestamp is older than, I don't know, 10 milliseconds, it will basically, oh, I noticed something was wrong. I wasn't running for a while, so here the last freeze duration, I think it's around 200 milliseconds, 215, and down here it's 270. And this number down here is from the outside of the process, so it's, yeah, it's always a bit larger. But you can see it like it migrated a whole gigabyte of data in just a few milliseconds, but the data wasn't actually migrated during that time. It was slower than that. But it just migrated the minimal state to get the application up and running, and all of the rest is done lazily. As I said before with the lazy migration. I'll get to that in a second. But yeah, that's essentially the demo. So how does this work? Same graph as before, just this small change here. So now we pull the checkpoint, but the checkpoint doesn't contain any application memory. The checkpoint just contains the bare minimum to start the application. In my testing, that's a few kilobytes of data that needs to be transferred. And then after these few kilobytes have been transferred, the container can already be started on the new node. These are these 200 milliseconds that you saw. And then it will lazily pull memory pages as they are needed. This is done via user-fault-D. It's a Linux thing. Basically, it's so that user space applications can notice when memory access doesn't work, so they can pull that from somewhere else. I think most VM live migrations also make use of that. So yeah, there's some caveats here. Currently, this just does lazy migration. You could do more optimizations by pre-copying, and then you would only need to lazy migrate what is left. But pre-copy also has some issues. It doesn't work on ARM, for example. So yeah. Ephemeral storage is not migrated at the moment. So if your container writes anything to its ephemeral storage layers, this is gone. It can't work with stateful sets because, as you've seen, these two pods need to be active at the same time. One needs to be terminating. It will wait during terminating for a new one. And that just doesn't work with stateful sets because stateful sets, they always wait until the old pod is gone and the new pod has the same name. Does it work with PVCs, so with storage attached? It depends. I did some testing with our storage system, and I think it should work. But yeah, I'm not completely sure this will always work out, because the thing is, the unmount will happen after the new pod is already started. Although Creo makes sure that your application won't run twice. It will make sure of that. But it could be that something else also writes to the volume, and that's usually really bad if you have block storage, if two different nodes write to a single volume. So yeah, this requires multiplexing. Yeah, read-write many, of course, that will just work. But who wants to use that?
I would like it if it's fast.
That's true. So yeah, one more thing. Live migration only works with one container within a pod. If there's two containers that want to live migrate, there's issues with that because the start-stop order of containers is not guaranteed. I actually implemented all of it, and then it worked, and then it didn't, and then it worked, and I got really confused. And yeah, at some point I noticed, okay, this container is stopping this. This pod is stopping this container first, and this one starts the other one first, and they don't match, so they can't live migrate. And it won't start a second. They don't do it in parallel, essentially. So that doesn't work at all. So it's currently just that just works for the offline migration. Yeah, live migration requires user faulty to be enabled on the kernel itself. Some distributions of Linux, they just don't enable it during build, which I noticed this morning for Flatcar, which we are using. So I couldn't show the demo on a real cluster. Yeah, we need to rebuild the kernel or use a different OS. I think most other OSs I checked, like Ubuntu and those kinds of OSs, they enable it. So yeah, what's next? This is very much still in development. I hope I'll release it with the next version of ZeroPod. By the way, ZeroPod is on GitHub. Just check it out. I didn't put the link. Live migration will be optional for now. Yeah, because it's kind of experimental, and it also requires some features that not every Kubernetes node might have. And yeah, there's some patches I actually wrote for Creo. I actually left out quite a bit from this graph because here the memory page is pulling. This is done by starting a Creo page server on the old machine. It's just a component of Creo which serves the memory pages usually over network. But the issue is Creo just binds it to 0.0.0 host network. Doesn't work that great in a container environment because now you need to open ports and it's unencrypted and anyone can just pull these images. It just doesn't work. So I changed it so it can listen to a local socket file, and now I'm doing like a proxy which proxies the socket, and on the other side the same thing. Yeah, it's a bit complicated, but it works. Now all the memory pages are pulled over an encrypted TLS tunnel, so that's good. So yeah, that's it. Do you have any questions?
What if I had open files in the process, like for example, to an image file? Probably the image works because they are probably at the same, or not?
Yeah. So if your file is part of the container image, like of the root FS, that should work fine. Creo will take care of remembering which files were open during checkpoint and recreate those file handles and all that stuff on the new node. And your program shouldn't notice that this file should still be open. That should work if the file is there. But if the file isn't there, you're going to run into issues, yes. Yeah. Yeah.
What about migration? Is it possible to migrate between clusters?
He asked if it's possible to migrate between clusters. No. This is, yeah. Yeah, technically, I mean, Creo allows you to migrate from anywhere to anywhere. It doesn't really matter. It just needs to be Linux. But yeah, this whole thing just works on a cluster. Yeah. Yeah. Thanks.